Bullshit. That means it's got silver mica disease. That's what that means. And you can hear it in the AM too. It's doing it on both, but they're stacked IF, and some of the cans are stacked. So let's see if we can get it to do it on AM. The camera is interfering with it. So we're going to have to do silver mica surgery on an FM, which is great. So obviously this is going to turn into a two-part video. That wasn't my intention, but you know, it's always the risk. That's why you run these things. And it's definitely a risk with the 50 stuff because the IF cans, the way they're set up. Let's see. This is the FM mixer. IF. This is what, the first IF? First, second. First, second. And limiter or third. So we've got 2 in here, 2 in here, 2 in here, 4 in here. I'm gonna have to see how this is set up because there's one of these, the cap goes through here, but it just passes through. 3 here and 3 here. These ones are really hard to do because you know, you got to figure out. Let's see, 3, 4, and 6. So 4 and 6 must be tied together. Yeah, this is going to be fun to figure out. I'd like to be able to measure these if I can, because that'll make it a lot easier. Otherwise, I got to put trimmers in here and find all the values. Now, luckily, I haven't touched the IF cans, so they're set probably wherever they're supposed to be, and it seems like the alignment's good when it's not having issues. So all we need to do is just figure out the values. We're not going to touch the cores. So let's systematically go through this and see how we can potentially do this the most painlessly. I think I'm going to try and measure these without doing trimmers. So try and measure them and then replace them. And if I'm looking at this right, if I use my brain for a second, which, you know, is unusual, I think in this case, if I remove the can from the set, if I measure from 7 to 3, that's going to give me this capacitance right here. Pretty close. There's some lead length and stuff, but that'll give me that capacitance. If I measure between 3 and 8, that'll give me that capacitance. If I measure between 4 and 5, that'll give me that one, no problem. So the only one that I'm going to have to figure out, I'll probably just disconnect one side of the coil, is between 3 and 2. So that's that one. This one, I have no choice. This I'm going to have to do just like you do an AA5 one, which I've done a few of those before now. You're going to have to disconnect one side of the coil on each of these in order to measure those, but you can measure between 2 and 4 and 6 and 8. If we come down here to this one, same thing. I'm going to have to disconnect one side of the coil here to measure this one. I have to disconnect one side of the coil to measure this one. But I can measure this one right here, 6 and 3, without doing anything special. So that's what, 3 cans so far? Same thing here. If I measure between 4 and 5, I have to disconnect one side of the coil. But if I measure between 5 and 8, I could not disconnect anything. I can get this value just by removing the can and measuring 5 and 8. So I only have to disconnect one thing in this can. Same thing here. Disconnect one side of the coil and measure on both of those. This one I have to disconnect and measure this one. Let's see. This one's going to be tricky. This one I'm going to have to disconnect 2 sides of this coil, the center tap and one side of the coil in order to measure this one. So there's a few of them that are tricky, but I can get quite a few values out of here without disconnecting anything. This one, these 2, that one down there. So it's not going to be easy, but it's not going to be crazy hard. I'm as ready for this as I can be, so that way I can screw this up and it'll never work again. I marked all the coils, or all the transformers rather, with the number on them. I started writing the the slug numbers on them, but that's useless, so I just quit. I just put the coil numbers on them. They're labeled by L. They seem to always be in SAMs. And I also marked the edge where the arrow lines up, so that way we know we're getting them back together correctly when we take these apart. If you've ever seen this, see, I got it marked there, there, and there. That lines up with the arrow. That's on the bottom. It's hard to see it in the schematic, but there is an arrow on the phenolic on the bottom. So I'm just going to do it one at a time. We'll take one out. We'll see if we can measure it. I think I'll probably do, this is the most complicated one right here. Most complicated to get out because of the number of connections, but I should be able to measure 3 out of the 4 caps. So this is probably the most difficult one to get out. I opted to just leave the components on it since I could. No need to heat up those resistors any more than necessary, and it holds the lugs in. I've had these Zenith ones apart before, whoever made these particular ones. And these lugs, when you start clipping the capacitors out of them, they start to fall apart. I think having these soldered together like this will definitely improve the chances of it not coming apart. So you bend these little tabs back. Like I said, I've taken these specific ones apart before for an AM. I've never done an FM, which is going to be a little bit more complex. And take the cover off of it. And I believe this bolt in the center is holding the capacitors together. It's what keeps pressure on it. So we're going to try and leave it intact for now, and probably I have to look at the schematic for this particular can, but we want to take the coil out of circuit and try and measure these. So Shango's covered this many times. These all kind of look the same, although this one's got more capacitors in it than an AA5 does. And you can kind of see how this goes. So I can see that there's one coil attached there, there's the other coil attached there, and of course there's other capacitors in this one. We'll have to take a look at the schematic. But that little mica wafer, see it down in there? See, this holds it together, and these terminals have little pads on them, and that's what defines the capacitance, is how big that pad is, and the spacing and everything. So we'll see if we can take some measurements here. I may have to disconnect some of these resistors. After all, thinking about it, if this is one of those ones where I can measure it in circuit, if there's a resistor there, I'm going to have to 86 the resistor. So I'll take a closer look at this, and we'll show you how they measure out once I figure that part out. In my attempt to be clever, it's kind of come back and bit me because the resistors put the coil in circuit, which you can't read it. So you can't have these resistors hooked up. So I've got this one desoldered and just floating in the hole right there. So we should be able to read between pins 4 and 5 now. Let's see what it gives. We got a couple picofarads in the leads here. They're a little bit long. 34. I don't know if that's showing up in the camera or not, but 34 picofarads. So that's probably like 30 picofarads, I would guess. So we're going to just write down what they are. It'll be close enough, I think, 34. So I'm kind of curious maybe if I could shorten the lead length, or maybe I can put the tester directly on it here, on these leads, and we'll see how much capacitance there is in the leads. 31 picofarads. So we got about 3 picofarads in the leads. So this is where we write this down on the schematic, and we're going to write down, I bet that's supposed to be 30. It's reading 31. We'll just put, I'm going to subtract 3 picofarads from every one of them because of the lead capacitance, and that'll be close enough. Now, of course, I'll share this with the community, so the next person that wants to do this, I actually probably should have looked and saw if somebody had already written these down, but I should share these with the community. Okay, so for this last one, I disconnect one side of the coil. It's reading 33, so that's 30. So I'm thinking this thing had, let's see, what was the first one was 30? Yeah. Yep, exactly correct. It was reading 30, 31. We'll call it 30. So it's 30 and 30, and 143 and 143. So we got the first can figured out. Now the question is, I got a lot of mica caps. I don't know if I have these values. If I've got ones that are within a couple of picofarads, that'll be good. Okay, so here's how we're going to do this can. I can do it all with, I'm doing this with what I got. You know, I may need to order some, but it's very rare that you're going to find the exact values that you need. Well, depends. Anyways, you can certainly parallel capacitors, and that's what we're going to do here. So to get the 143, we're going to use a 120 and 24. It's going to get us 144. That's close enough. And I'm assuming lead length is about 3. It was reading a little bit higher. It was reading like 146. So it's going to be right in, it's going to be in the ballpark. And then I can take the 24s and add 5 and get 29. That's 29 and out of 30. So we can do it all with the values that we got here. I may run out depending on what the other cans need. I may have to order more. But we can certainly repair the first can and get it functioning with just the, we're going to do one can at a time. We're going to align it, do one can, align it, one can, align it. Otherwise, we're never going to get the thing right. So at any rate, let's gut this thing. I got to take this nut off of here, gut it, cut off the pads. This is a pain in the ass. It really is. Okay, here's a prime example of silver mica disease. This is the wafer. I broke it up and took it out. And see all this black right here? This is where it was arcing through. That black is the arcing. I don't know how well this is going to show up. But and then this white is tarnishing. That shouldn't be tarnished either. This wafer, where it's clear here, that clear parts, it should be clear like that all the way around. It shouldn't look like this. So it's just dirt and moisture over the years. They go bad. This is a problem in these sets. I'm not, Shango's talked about this a million times. I'm not telling you anything that you don't know if you watch his videos, but this is a little bit more complicated because of the number of capacitors in it, because it's an FM. If this was an AM or an AA5 radio, there's 2 coils and 2 caps. This particular one, I think, has 4 caps in one can alone. So it's very difficult to do this. So now we have to cut these tabs off of here. See, they're different sizes. That'll give you different capacitance depending on how close or far away they are in the mica. These will be a dead short now if I don't cut at least one tab off so they're not touching each other. So let me do that. Screw this back together and put the caps on the bottom of the IF can. It ain't pretty, but it'll work. So hopefully I get the clamp in there. Once I get this all situated and soldered back in and everything, we got to make sure we don't have any shorts. But there's 1, 2, 3, and 4 caps. Unfortunately, I had to do combos to make the values work like I said before, but that's what it takes. Well, I've checked it as best as I can for shorts. Doesn't look like it is. I'm a little concerned about that one cap that ended up down there. I won't put them that close to the terminals again next time. I learned my lesson about getting that clamp in there to hold the can. You probably can't see it, but it's down in there. I don't know. What's the under over that it's going to blow up? Shall we give it some juice? Well, that's a good look. Got the speaker hooked up. See if we get anything, if it's even, in theory, it should be in alignment or very close. So we'll see. Got a neon light, so I know it's got power. Well, and the dim bulb came up. That sounds like a dead radio. So I've got something hooked up wrong, something shorted, something along those lines. It's most likely. It wouldn't surprise me with the amount of work that I had to do in here. Oh, no, we do have something. That's volume all the way up, though. So that's AM. That's interesting. Okay, so AM's good. FM is dead, though. Well, it's not dead, but it's way out of alignment. Well, I fucked up, which is no surprise. I don't know how the hell I did this. I thought I checked my work, but I've got caps hooked to 2, and they're not. They're supposed to be on 3. It explains why I couldn't do anything with it. The thing's working like shit. And that's why I should have checked my work better. You know, I make mistakes all the time, and that's okay. You know, you just learn you got to slow down a little bit. It's not a big deal. I can clip these capacitors and hook them to where they're supposed to go. Boy, what a hack job this has turned into. I'd extend the lead, which is going to change the capacitance slightly, not enough to matter. But I got them on 3 now. I did check the other ones. They appear to be correct. I think I got between 2 and 3, which is right. That's for 1 coil. And then 4 and 5, I remember that was the pass-through, so that should be right. So I think we're good now. I just somehow put those on 2 instead of 3. So, I see, I got that hooked up right. Cheater cord. Engage. Let's see what we get this time. It's probably going to change the performance, I would hope. Now that I tweaked with the cores, though, too, so now it's probably all screwed up anyways, but let's see. That sounds more right. It sounds out of alignment now. It doesn't sound all distorted and screwed up. Double hump. All right, much better. Let's get that core line now. So to further complicate this mess, we're losing tube filaments because I can see it going in and out. I don't know if the camera's going to pick it up or not, but the tube filament's going in and out. So we got a flaky tube. I think we got a flaky tube somewhere. See, it's going out now. Let me see if I can figure out which one it is by tapping on the tubes. You see, there it came back again. See it burning? See how it's getting dim? We're losing the filament string. Alright, so bad 12BA6, which I think there's 3 12BA6s in this one, and I happen to have a couple of those in stock, so we're good there. I had to go through and substitute because it was flaky. It's impossible to figure out where it's open because it's going in and out, in and out, in and out. So I just started substituting one at a time. I got another set that's got the same tube complement in it, and then was able to substitute. So anyways, figured it out. Got that nailed down. Now, I started thinking about this IF can, or actually this is the discriminator can. Made a very stupid mistake. I made a very stupid mistake, and I said something inaccurate earlier. I just wasn't thinking with my brain and my skull, which is typical. Remember how I said, oh, the way this is arranged, you could measure 8 to 3 and 7 to 3 on here? Well, I I definitely screwed up. It's reading through this coil. This coil is low resistance, so it doesn't really matter that it's not going to be able to, that tester's not going to be able to tell that this was in circuit. So what was happening was when I was reading 8 to 3, I still had this capacitor in circuit. So it's like having two capacitors in series. In parallel, and so the tester couldn't see the difference. Now, remember how I also mentioned, I wonder if somebody else has dealt with one of these sets. Well, I went online and checked, and somebody did go and get the values for these. I checked the model number of these cans they're actually in the chassis, that other radio I was talking about. They're the same cans that are in here. It's a 1952, this is 56. So I did write down the values that he had listed. He was showing these at 68. I'm showing it at closer to 70 or 72. 68s. I think I have 68s, so we'll just put 68s, and it's probably close enough. The rest of these were 27s over here. I'm going to measure them anyways when I pull these apart. He showed 270, 120, 120. 120, 120. The 120s don't surprise me. That's very common value for 455 for AM. But these other audio bypass ones and stuff, they're kind of tricky. So anyways, we do have values, but I'm still going to measure them as I do them. But I'm very anxious to see if I take these, what did I put in there? 140 somethings, right? I think 146 or something like that. I put in each one of those, and they're supposed to be around 70, 68. I've got some 68, so I think I do. So we'll swap these out. It's not most likely. I'm sure that's what happened. I'm sure I just screwed up. So now that we have the appropriate capacitors hacked in there, let's give it a shot. I expect it's going to work. However, the alignment's going to be totally jacked because I was trying to align it, and I did the cores all the way out, and it was still getting closer to where it should be. I knew something was wrong, and I just couldn't figure it out. That's kind of how I came to this conclusion that there was something wrong with the values that I picked. So anyways, should be right now. Let's try it. And I'm going to have to get in here to the core I need both hands to get to the core, and I'll start. If they're so screwed up now, I'll just tweak them till it sounds right, and then I'll throw the generator on it and stuff once I'm a little bit more confident. Okay, so this is no alignment, and it already sounds way better. It's low, but that's okay. It's just because it's out of alignment. It's not bad though. It's working way better. So yeah, dumb move. So my advice, and it's funny. I was talking to Shango this morning about this, and I told him, I said, if I could give anybody any advice about this, disconnect everything. If you're going to go into the can to check these, you may not see something in the circuit. So if you think you're going to be suave and save some time measuring these, you're not. Just take everything, take the coils off both sides, and just measure the caps. So we're good. We got the discriminator coil working. I got the tube issue solved. So now it's just a matter of going through and doing every can, and that's painful. It really is. So let me get through some of these cans. And just real quick, we did align the discriminator coil. No problem. I use the voltage method. The electronic scope doesn't... I need to get a real scope. It doesn't work very well trying to do alignment. So the lower coil, you adjust that for maximum deflection. So we got the maximum voltage out of it. And the upper coil, you adjust that for 0. So that's your 0 point. So max deflection and 0. Maybe what I'll do here is put this up on a tripod. I'll remove the next coil, and I'll just film that. You can fast forward or whatever. If you're interested in watching me gut one of these and do all the work, I'm just going to go ahead and do one of them, and I'll just film the whole thing. All right, so I'll put you up on a tripod. We'll just show this real quick. I'm going to remove the coil, and then I'll show you actually gutting the can, this has been covered multiple times by Shango, but I'll do it here with these specific ones. So this is L9. The one that we just did was L11. This was a more complicated one because it has so many caps in it. It's got 4 caps in it. If we go to L9 here, and here's L9. Let's see if that's in frame. L9 is a 10.7, and it only has 2 capacitors and 2 coils in it, so it's only a 4-terminal. This one is easier to do. This is a lot easier to do, and it's going to be easier to get out. It's more accessible. It's got more room. It's got less things to unsolder. So all I'm going to do is just remove. In this case, I'm going to remove all the wiring from the terminals itself. It doesn't have a bunch of capacitors or resistors that jump across. So let me remove this, and then we'll cover gutting the coil, measuring it, gutting. Boy, Jesus Christ! Let's try that again, shall we? We'll cover removing one side of the coil, measuring the capacitors. Even though I know what the values should be, they may be a little bit different here, but these would be. I could take what I found on the internet and put them in here, but we'll measure it anyways because a lot of times you don't have the values. I just got lucky this time that I found somebody had already done this. So we'll cover measuring them, gutting it, and putting the appropriate values in there. Okay, just real quick, I desoldered them. You can see here and here and here, right? I left the leads in on this one and just desoldered everything from the can. It was the easiest way on this particular one. Also, I forgot to mention, you can't see it, but I put a yellow mark to line up with this arrow because these cans are marked. And you can't see it, but there's a little arrow on here, and that's how you know how the numbering goes. It tells you on the schematic. I put a yellow paint pen mark down here so I know what direction it goes back in. Just like I marked the can, so I put the can back together the same way. Got this angled so you guys can see it. I'll show this one, and then I'm going to do the rest of them. And unless I run into something crazy with those to show you, I'm only going to show you this one. This is the easiest example. With these, you got to bend these tabs back out of the way here. That's how you open these up. You take the can off of it. Just carefully bend the tabs out. There's different ones. There's all different. I got another radio that I need to do that is more complicated than this. It's that 46 Zenith, the very first FM, AM, FM. I need to do that one too. It's got silver mica disease real bad. So you bend those out of the way, and this literally just comes out. So you can see we got 2 coils in here, and there are 2 capacitors, and that's what this is a capacitor in here. So let me show you how to gut this one. Maybe we'll just keep rolling here. So, and remember, I got my mark on the can here, so I know that lines up. That actually lines up with this mark right there. See it? Before I take this apart, I need to unsolder one side of the coil on each one, because I want to measure the capacitors in this. Now, like I said, I've already written it down. They're supposed to be 27 and 27, but I'm showing you guys how to do this so if you don't have the values. And who knows, we may be a little bit different here. So I've got to desolder the bottom coil, 1 lead. You only need to do 1 lead. 1 lead of the bottom coil, 1 lead of the top coil. So I'm going to put this in here, and we're going to do one at a time because I don't want to cross anything up. So this is the bottom coil. So these 2 make up, geez, I can't keep this in frame, can I? These 2 make up 1 cap. These 2 make up the other cap. So I'm going to desolder one side of this first, and we're going to measure this one right here. So I'm going to get my tweezers out here if I can find them. And we'll desolder one side of the coil. We have to be pretty careful. We don't want to break the wire doing this. Okay, so I got my tweezers here. I can see this is the lower coil. I'm just going to go after the one that looks easy. Hopefully this is in frame. All right, got it desoldered there. Hopefully you could see that. So we went ahead and desoldered this. Now, if you're not familiar with this, you can't leave that coil in circuit. If you leave that coil in circuit, it's not going to give you, it's going to give you a resistance reading is what's going to happen. And now I remember with this, I've got my little M tester here. There's about 3 picofarads of resistance in the leads that are in here. So this should be right around 30, I'm guessing it should read. 28. So there you go. The guy had said 27. It's 28. That's spot on. That's right where it should be. So I'm going to resolder that on there now that I know that it's 28. I'll write down what my values are. It's only off by 1 picofarad. So 27 is probably accurate. Well, now I said that my leads had about 3 picofarads in it. So I could probably get away with putting 24s on here, but I'm not going to do this like I did the last one. I'm going to install it and I'll put them on the bottom afterwards. I did that one because I thought it would be hard to get to. So let me resolder this and we'll check the other one. In theory, it should be the same. Now I'm just going to very carefully place this back on here with my shaky hands and my vise that isn't tight enough. You don't have to have this off to remove the capacitors. This is just to measure it. Okay, so we got a good solid mechanical connection there. We'll just retouch this real quick. My soldering iron went into standby. Okay. That's all it takes. You don't need to put a ton of heat on it, just enough to get that soldered back on there. So we checked the lower coil. Let's do the upper. Okay, I'm going to remove, I think maybe this one. This one looks like it might have less wraps on it. This is how you do it. This is a very tedious, painful kind of thing. And if you know you're going to do this repair for a customer, you know, you got to make sure you put your time into this because it's tedious. And the other thing, anytime I take anything external, if I take any repairs for anybody that I don't know, I always tell people, look, you can't get parts for this stuff. It's possible in order to repair it that we might destroy it and that there might be a part that we can't get for it. So I always disclaimer that because, you know, 28 picofarads on the nose. So we know we're right in that range. It doesn't have to be perfect, but you want to be within a couple of picofarads because wildly can throw it off. If you're off by 5 picofarads, that core is going to be all the way in or out. So I'm measuring them at 28. They said 27. I might put I have some 2s and 3s, I think. I might get it right on 28, 27. Like I said, my leads, I think, are about 3, so it could be 26. Right in that neighborhood. We want to be like 26 to 28. We don't want to be any further off than that. So we just reinstall our wire here from the coil. Delicate work, and we'll resolder that. Now we're going to gut it after this. All right. Next step, disassemble the coil. Isn't this fun? Isn't this boring? Gonna take this nut off the bottom. Whoop! Well, now I probably just destroyed it. I need to be more careful. I'll do this holding it in my hand. Back this nut off. You take this nut just about all the way off. You don't have to take it all the way off because you're not going to be, there's not enough lead length here to take this completely off. So what we're going to do is we're pulling this back. We're going to take this wafer out of here. You can see it's got silver mica disease, something awful. It's just a matter of time. The longer you run these things, the worse it's going to get. This one's pretty roached. So let's see if I can, it's hard to keep this in frame. Maybe I can widen this out a little bit. You just get in here and break up this mica wafer. If I can get something underneath it, it's might have gotten some contact cleaner under it. I'm sure that contact cleaner doesn't do it any help, that's for sure. There we go. So see, I got underneath it there. I'm just going to break it. We're going to take it out piece by piece. There. See all that migration, that black? That is conductive. That's carbon tracing through the capacitor, and eventually that will wreak all kinds of havoc. It should be clear. It should be clear. So now that we got that out of there, we still have to deal with the pads in here. So if you look carefully, you can see that there's a pad right here. See right there? We got to cut those off, because if you don't, you're going to have a direct short in here. Now, I'm looking at this particular one. I think because of the values, maybe they're spread out and they actually don't overlap. So I may not need to clip these. This one's not a good example. On some of these, you have to clip these pads off. So take a look at it when you take these apart and see if two of these are going to touch. If any two are going to touch, you know that you're no good. We got lucky with this one because of the way that it's arranged and it's only 4 caps. I'm going to look at this closer here for a second, but it looks to me like we don't need to do a thing. So yeah, after very careful, close inspection, we do not need to do a thing with it. So we just removed the wafer. We left those pads in there simply because it does help hold these lugs a little bit better than without them. If you clip them off, there's a little bit of metal left in there that still holds it, and that's not a problem. But if there's no need to leave them in there, it's because the spacing between the pads, in order to only get 28 picofarads, the spacing is larger. Because the capacitance goes down, I believe, as the spacing gets bigger. As it gets closer, just like if you're tightening a trimmer, your capacitance goes up. So at any rate, we can leave that alone. I might be wrong in what I'm saying, but logically that makes sense to me. So, all right, all you gotta do is install it now. We just gotta put it back in, and we'll install the caps on the bottom. We're gonna know where they go because we know how to count these. This would be terminal, according to the schematic, on this side of the arrow. This would be 8, 7. It's actually 8, 7, 6, 5, 4, 3, 2. So this only has 2, 4, 6, and 8 in it. And if that should coincide with what's on the schematic, and it does. If I read the schematic here, we got 2, 4, 6, and 8. So perfect. Okay, so we got them installed. I ended up at 26. So, because I know my leads have a little extra capacitance, so if it was 27, what I read on the internet, 26 is going to be close enough. So 24, 25, 26, between, what was it, 8 and 6 and 2 and 4. Yep. So we just stuck them on the bottom there. It's not the most pretty thing. The leads are a little bit longer than I wanted, but that's not really going to matter. It's just how I could get in here. I'd rather it be a little bit more sloppy looking and not break this thing trying to stuff this stuff down in here. So it should work. Really, the alignment should be very close if my values are close. So, but we'll have to tweak the cores because they're new capacitors and it's going to be a little bit different. It's very sensitive. But we'll fire it up and test it. I don't think I'm going to go through and align it every single time. That's just too much work. I don't see the necessity there. I'm relatively certain of the values here. It's not like I need to find the values by putting tuning trimmers on it, by trimmer caps. So I should just be able to plug it in and try it. Yeah, so it works. So the alignment's not great. It's not very loud. So I'm sure it's off by a little bit, but that's okay. So anyways, I showed you how to do one of the cans, and then of course I talked about the other one as I was doing it. So I'm going to go through, I'm going to do the rest of the cans. Well, so far this looks like a complete idiot did it, which is true. I hate having these capacitors paralleled in here, but I'm not going to buy a bunch of caps right now, and I've got a whole variety of these. So it happened to be this coil right here, which is one of the 455 coils for the AM. I happen to have two 120s and a 270. This one was interesting. I measured it, and it measured at 205. And the info I'd found online was that it should be 270. And thinking about this circuit a little bit, it seems like 270 made a little bit more sense where this is. And that did improve the AM performance a little bit just when I checked it out. So I got 3 out of 6 cans done. I'm going to keep going. So the alignment's still pretty far off. I'm on the second to last can. I just finished it. I got one more. That can was pretty far off as far as the capacitor values. So something interesting I'm learning as I'm doing this, measuring them versus what I found on the internet, and I would suspect that the numbers that are on the internet are more accurate because they just sound right. For an FM circuit, they're going to be around the 30 area. These were reading like 50. Same thing over here. For the smaller values are reading high, it seems, and that's probably why the alignment is not quite right. I am finding that it's really the black stuff in these where it's bridging. And this isn't going to focus probably, but it's definitely, the mica was definitely going bad in it. So some folks say that these larger cans don't go bad, but they do. And even the ones that weren't bad were going bad. You can see it creeping. And eventually, you see those little streaks in there? And I don't know if you can or not. Yeah, this just isn't going to quite focus. But the little black streaks, eventually they're going to bridge to something. So in my stuff, I don't care. When it goes bad, I'll fix it. But I got to do a wholesale on this because this is getting shipped to a customer, not here. So it's got to be perfect. So at any rate, it's got one more to go. All right. Every can has been recapped, and I'll tell you, it's a lot of work. It's a lot of work. So, it helps having the values to go against. Like I said, I got another radio that I need to do that there's no values for, so it's going to be even harder. And it's got 4 slugs in every can, not just 2. So this is kind of good practice. Anyways, so this is what we got. There's definitely alignment issues, but I think it's certainly alignable the way that it is. It would not work well at all. I mean, not much volume, and I can receive pretty well. So that tells me it's not that far off. If I had made some grave mistake in the capacitance values or something, it wouldn't work at all, or I'd have to crank it to hear it. So now it's just to do an FM alignment, so we'll go through that. We're just going to follow the procedure. I'm probably going to use the voltage method. I've had better luck with that over the years. The sweep method, it's just never worked right for me. Okay, we're set up to do an alignment here. You start with the AM. Here's the instructions. We want to follow this procedure from top to bottom. You start with AM, and that's important that you do that because the AM can influence the FM because of the stacked IF. So the first thing that we've done is we're injecting 455 in to the 12AT7 here. We're going to adjust A1, 2, 3, 4, and 5. The interesting thing, and I'm just going to follow this, the interesting thing is, and it's been a while since I've aligned an AM, FM, and they might be this way, but it shows the top and the bottom. A1 and 2 is 10.7, so it's not 455, so I don't know why. I think it's because of the stacked IF, but it just feels weird to me. So A1 and 2, A3 is right here, which is on top. Let's see, where's A4 at? Did I lose it? A4 right here, which is 455. So A3 and A4 are both 455, and of course the bottom is 10.7 on this one. So, I don't know, that's interesting. I wonder if this is wrong, because I can't imagine you touch a 10.7 coil. A1, 2, 3, 4, and 5. Well, we'll just do it. If we screw it up, we can always fix it. So we'll do A1 and 2 first, which is this coil right here. I actually wrote it 1 and 2 on here. I didn't write it on all of them. So we're going to do the top and the bottom and just peak it. We got it on the voice coil, so AC, voltage. It's just measuring level. You can do this by ear. You don't need a meter for an AM alignment. Well, that sure woke it up, didn't it? That was already peaked. Alright, that coil's peaked. So that's A1 and 2. We're going to do A3 and 4 next, which A3 is going to be the top, this coil here, and it is the top. Okay, so we peaked that one. We're going to do A4, which is the bottom. That is the bottom of this coil right here, L7, or excuse me, L1. Is that L1? No, it is L7. It is L7. So we want to do the bottom of that coil. Looks like that's about peak. That's A1, 2, 3, and 4. We're at minus 87 dB. We'll leave it there for a second. Okay, next we want to do 5. A5. So oh, that was A5, excuse me. So I did 1, 2, 3, and 4. 1, 2, 3. Oh no, no, I want to do 5. 5 is on top. So that was the bottom. I want to do the top now, which is A5. It looks like that was already peaked. All right. So that is the AM alignment sequence. Okay. We're set up to do an FM alignment. So we're going to start with, of course, half microfarad, or 0.05 microfarad, which is what I already had. We're going into the 12AU6 this time. Pin 1, the grid of the 12AU6, 10.7, unmodulated. I thought about putting some modulation in there, but it might screw it up a little bit. And they tell you to put the DC probe on the point A, which is what we've done. They tell you to use a 2 meg resistor on a VTVM, but since I'm using a DMM, it's not necessary with that. So, all right. We've already done this because I did align these coils already back when I did the first can, just because it was a complicated one. But we'll do it again. We want maximum deflection, and we're going to adjust A8. A8 is the top, excuse me, the bottom A8 of the discriminator coil is the bottom. So in theory, this should be right on already. And I'm not seeing any change, so I must have done something wrong here, because that should be changing. Let me double check my connections here. Okay, so yeah, I had it hooked up to the wrong terminal. I was on pin 7, I think, instead of 1. It's hard to see it looking down there. Anyways, okay, let's get back to this. So we're going to adjust at point A for maximum deflection, which I think it's pretty close already now. Let's see, it was off a little bit. So you can see the voltage starts to drop that direction, and it starts to drop that direction. So we peak out right around here. Let's drop the signal level. Yeah, that's about it. That's peaked. So now we need to move to point B, which is right here. So terminal 5 is a good space, is a good spot on the IF can. So we'll move the lead over to there, to number 5. Okay, we want to adjust this for 0, and this is going to be A9, which I believe is on top. Let's see, where was that? Just trying to show you guys the right way to do this instead of the wrong way. A9, which is on top of the discriminator can. You can see there's clearly a peak there. We want this to be as close to 0 as possible. So see, the voltage is going up, or well, negative, but it's still going up. And then it goes up there, so very touchy. That's about it. That's about as good as he gets right here. Yep, there we go. So the discriminator coil is now aligned. We're going to move on. Isn't this fun? Isn't this like the most boring shit ever? You guys really want to watch this? We're moving on. We're going to go to the high side of pin 1 on the 12BA6V4. There's a couple of 12BA6s in here, so you got to be careful. We're going to go to valve 4, which is a 12BA6, and we're going to go to test point C. So let me get set up for that. Okay, we're set up to do the next step here, which is number 6. We are on the 12BA6, point C, adjust for maximum deflection. Deflection. So that's this guy right here. Touchy, touchy, touchy. See how it crosses over real quick there? 7, 6, and then as you go, you get up to 0.8, and then it drops off. That's exactly what it should do. Okay, so we're going to be somewhere around 880. Okay, that looks like that coil's peaked out. Let's move on to the next one. We're going to go to valve 3 now. We're going to do the same thing. We're going to go to A12. It's just progressively working down the line. So let me move it over. Okay, so now we do the A12, only A12 in the bottom of this can right here. I don't know if you can see it or not, but let me zoom in a little bit. Yeah, pretty darn close. There we go. That's peaked. Peaked enough. Okay, we'll move on. You leave the meter. At this point, we just leave the meter on the same point, apparently. Now we're going to go to the pin 2 on the 12AT7, which is the RF amp. We're going to go pin 2 there, and then we're going to adjust 13 and 14. So that should be pretty easy at this point. We're almost done here. Okay, running out of camera battery, so I better hurry up. A13 and 14. So let's see if I got this hooked up to the right place. We want this can, and 13 and 14 are the top and the bottom. Oh yeah. Look at that. Okay. Hopefully everything's falling apart on me here. This bench is a mess. Okay. Let's do the top. I'm hearing background now, which is exactly what I would expect. That's how far off the alignment was. That's about it. I'm not hearing the background though. Let me double check this here. I don't know if that means anything, but yep, there we go. That's peaked out. The alignment should be spot on now. So if we disconnect, we turn off the signal generator and we disconnect it. Yep, that's what I would expect. Oh yeah. All right. It's looking like we got a good alignment on this thing now. So, you know, it's better to do it with all the shields and crap in place. I guess I should have put the bottom back on it. So, you know, criticize away, but there you go. There's a FM alignment using the voltage method. So FM alignments are a pain in the ass. I'd like to do a sweep alignment someday. I've never had any luck doing it, but I think a lot of it has to do with my scope. All right. We got it working pretty good now. I did make a mistake somewhere along the line because when I went to sweep through the stations, I noticed there was a double hump in there telling me that the alignment was not right. And I traced it down to L9 here. When I aligned that, I actually had the voltage. I was checking the voltage on the wrong point. You got to be careful. I counted what terminal it was based on the position of the arrow on this can, which is over here. And it's on this can, it's here. I counted from here. So you got to watch out for that. I like pointing out my mistakes. So I had aligned it incorrectly, but wherever I was measuring the voltage from was still giving me a reading that made sense, so I didn't catch it. Anyways, we're good. It sounds good now. It's got a nice wide tuning to it for each station. Some of the stations that are really close to each other, especially K-Jazz, because it's weak and it's really close to 88.5, I think 88.1 and 88.5. I think K-Jazz is 88.1. They almost bleed into each other, but you're going to get that with these AFC units. So anyways, put the bottom back on it here in a second. We'll get it back in the cabinet. And the filter started getting warm. So it's warm and the cans around it are not. So I guess I know what that means. Okay, that's taken care of. Let's see if I screwed anything up. Oh well, it would help if I plugged it in, wouldn't it? Let's try that again. Well, that's a good look. And that's a good sound. Okay, FM. The alignment seems pretty good now. And that pretty much completely rebuilds this, other than resistors. But these things, the resistors can be off by 30%, 40%. Well, not quite 40. 30% though they can be off, and that's usually what they are. And they go up in value as they get older. But it gets plenty loud. The alignment seems good. So it's going to go back in the box. Thing sounds pretty damn good. It's working great. The alignment sounds good on it. It's got a lot of stations. Let's see if we get cage eyes down here. So it's at the independent 88.5. That's K-Jazz down there. And then Radio Guadalupe TV is right here. Yep. There's K-Jazz and then the independent. They're so close. Is it the independent radio? I think it is. Independent radio 88.5. They're so close to each other. It just doesn't quite... It needs automatic frequency control, and that's why all these radios after 1960 had it, because it just works so much better, and they drift. But it's working pretty good. Let's see, KR's right up around here. Yeah, that's KR's with the commercial on right now. Jeez. And then there should be a weaker. That's 105.1. That's a country station. It's strong, but it's not as strong as K-Earth or KLOS. That's the guy that owns this radio station, Saul. He's the one that had K-Surf, which is now K Mozart. The guy's delusional 100-year-old, but he's got the only country format station in LA. So let's see, and then K Rock, which is, what the kids now are calling oldies. It makes me feel like a idiot. It makes me feel old. That's K-Rock there. It's a commercial. There it is. Nice and clean. And it's not super strong here either, but it's, sounds nice and clean. It's full quieting. Star. Well, it used to be Star 98.7. Now it's 98.7 Alt, I think.
Good afternoon. This report is sponsored by eBay Motors in Linwood, eastbound 105 before Long Beach Boulevard. Stall moved out of lane, drop to the right shoulder.
Typical 19 T8. It doesn't like bass. So there we go. I mean, it kind of got it tuned in there. But anything with heavy bass, these 19 T8s, it just doesn't perform. They don't perform great. They're problematic tube. But see, now there's no more bass, and you're not hearing the distortion. KLOS. '94, the Wave. 93.1, Jack FM. Nice and clean. This thing's working good. It's working really good. All right. This has been a long one, and one full of mistakes and a lot of work. I probably got 20 hours into this radio doing the IF cans. This occurred over several days. where I could work on it. So, you know, definitely a lot of work. These Zeniths are worth doing it too. Other radios, I don't, unless it's an AM. These FM, there's a lot of caps to change in these things. It's a lot of work and it's a big dedication. It takes experience and time. I'm not that experienced that I've done these a few times now. You can see all the silver mica wafers laying around here that have been changed. But this one burned through. That one burned through. There was a couple of them that were just gone. The longer you run them, eventually they're all going to get it eventually. So you have to do this if you want to put these things into service. So, all right. That's a long-ass video. Let's wrap it up.